just show you long division. So I'll tell you now, if you're trying to divide by a linear and that's a monic linear, do not use long division. But there's one case you cannot really avoid long division, which is like you're divide by something not a linear, say squares. There will be other ways, but maybe long division is the quicker way to do it then. So I'll just show you one question, how to do long divisions. Let's look at the second one. Okay, let's look at the second one. For the second one, we have 2x to the power 4, and then we have x to the power 3. We have no x squared term, so we need to put 0x squared here, and then 13x, and then plus 10. And what we divide is 2x squared minus x plus 4. Okay, 2x to the power 4 divided by 2x squared. You use the first one to divide by the first one. Okay, the first one divided by first one in the decreasing order. So 2x to the power 4 divided by 2x to the power 2, you have x to the power of 2. Then you need to use the x to the power of 2 times with the dividends. So you have 2x to the power of 4 minus x to the power of 3 plus 4x to the power of 2. Okay, the first term must be 0, and the second term you have x to the power of 3 minus negative of x to the power of 3. That will give you 2x to the power of 3. Okay, 2x to the power of 3. 0x squared minus 4x squared, you have a negative 4x squared. Okay, you have negative 4x squared. And then you put this down, so you have plus 13x. And then repeat the things again. You use the first number to divide by the first number here. So you will have a plus x. And you use the plus x to time with the dividend. Okay, to times with the dividend. So it's 2x to the power of 3 minus x to the power of 2 plus 4x. Okay, plus 4x. So the first one must go on, the middle one, minus 4x squared, subtract negative of x squared. So it's a plus x squared. You have minus 3x squared plus, okay, so 13 minus 4, you have 9x. And then you have the plus 10. Okay, bring the plus 10 down. Bring the plus 10 down. Because you need 3 terms. You have 3 terms in your dividend, so you need 3 terms here. And the last one, use the first one to divide by the first one. You will have minus 3 over 2. Then you use the minus 3 over 2 to times with the dividends. You have minus 3x squared plus 3 over 2x minus 6. Okay, 4 times 3 on 2 is 6. So it's a minus 6. So for the constant, you left with 16. Okay, for the constant, you left with 16 because 10 minus negative 6, you have 16. Okay, 9 minus 3 on 2. Okay, 9 minus 3 on 2 is 18 on 2. So it's 15 on 2x plus 16. Okay, 15 on 2x plus 16. And you don't have any number left. So if x cannot divide by x squared, so your dividend is a quadratic, then your remainder must be a linear. And now I reach a linear at this point, then I will stop. Okay, we finish with this long division. And the thing we can write this in 2 ways. Okay, we can write this in 2 ways. So I can write px equals to 2x squared minus x plus 4 times x squared plus x minus 3 over 2, and then plus 15 over 2x plus 16 at the very back. Okay, that result times the dividends and plus the remainder. Another way to write this will be px divided by 2x squared minus x plus 4 equals to x squared plus x minus 3 on 2. That's the whole part. And now plus 15 over 2x over 16 on the dividends, which is 2x squared minus x plus 4. And you can simplify that a little bit, times 2 on both top and bottom. That's 15 on 32, so it's 4x squared minus 2x plus 8. Okay, two ways to write it. You can write px equals to the dividends times the result plus the remainder. Or you can write this px divided by the dividend equals to the result plus the remainder on the dividends. Okay, the remainder on the dividends. So you have px divided by dx, and then we have qx, and then after all this calculation, we're left with rx, which is the remainder. So you can write px equals to dx times qx plus rx. Or you can write as px divided by the dx equals to the qx plus rx over the dx. Okay, the second one will be the same. The first one, divide dx on both sides. Divide dx on both sides. Okay, so I'm not going to show the first one then. I'm not going to show the first one. So let's keep going with the second one. I'll ask you to finish that. And let's go to the next one. So last week I tell you it must be a monic-linear. Okay, it must be a monic-linear to use the synthetic method. Must be a monic-linear. But actually, if that's not a monic-linear, I can still use that method to do it. But we need to do some adjustments to that. Okay, for example, let's do this one. This one is not a monic-linear. I have 2x plus 1. Okay, so just to remember the method, I will write the coefficient in orders x cubed, x squared, x term, and minus 2. And I will try a number. I'll put the number in. The number must be make your dividends equals to 0. Then the x I need to put in is minus a half. Okay, it's minus a half. Remember what I put is x plus 2 equals to 0. I put minus 2 in. So similarly, I will still put minus a half in for this. All the way to create the table is the same. I'll put the 3 down. I'll put the 3 down, and then I will times negative a half times 3 plus 2. That gives you negative 3 on 2 plus 2 on 4, and that will give you a half. Okay, that will give you a half. Negative a half times a half plus negative 1, that gives you negative a quarter minus 1, which is negative 5 on 4, is negative 5 on 4. The last one is negative a half, negative 5 on 4, and go to plus negative 2, which gives you 5 on 8, subtract 8 on 16, that is minus 11 on 8. So you have minus 11 on 8. So that is the x cubed term, that's x squared term, that's the x term, that's the constant term. And later on to the box, you will have all the coefficients for your result. So this one will be x squared coefficient, that will be x coefficient, that will be constant coefficient, and that will be the remainder. Okay, everything reduced by 1. So that will be the remainder. Okay, but because that's not a monic linear, so all the coefficient will not be correct. So what I will do is I will divide by the coefficient. Which I will divide by this 2. Okay, because it's not a monic linear, I have a 2 in front of this x, so I need to divide that down by 2. Okay, divide that down by 2. So this part now I will have 3 on 2. That is a quarter, and that is minus 5 on 8. But this one will still remain minus 11 on 8. The remainder will not change. Okay? Remainder will not change. The remainder not required you to divide by 2. Okay, the remainder will be the same. Doesn't matter you divide by monic linear or like not monic linear. The remainder will be the same by using this synthetic method. But all the coefficient for x squared, x, and constant term needs to be divided by 2. Okay, needs to be divided by 2. I can show you the reason why that works, but I think it will confuse you. Just remember it, because there will be very little questions to give you like not monic linear. So I'll just show you how to use this method. Okay, so if it's not a monic linear, still do it normally as what you do for other questions, but like you adjust the coefficient for that terms, dividing the coefficient. Okay, dividing the coefficient. So what px divided by that equals to? Then px divided by 2x minus 2x plus 1 equals to what? 3 over 2x squared plus a quarter x minus 5 on 8 of the constant, and our plus negative 11 on 8, which is the remainder over the dividends. So that's 3 over 2x squared plus 1 on 4x minus 5 on 8 minus 11 over 16 plus 8 times 8 on both top and bottom. So you will have that. Okay, that's part 1, what equals to. And for part 2, evaluate p negative a half. So what does p negative a half represent? P negative a half is the remainder. Okay, to finding the remainder is making that dividends equals to 0 and you substitute that value into the px. And you find the remainder. But we know our remainder. Our remainder is negative 11 on 8. So p negative a half just negative 11 on 8. Okay, negative 11 on 8. So revise on what we have for example 2. Revise on what we have for example 2. We have px equals to that, divide by that. We worked out this last week, and then we know px equals to that times that. And now I want to evaluate p negative 2. So I divide x plus 2. P negative 2 is finding the remainder for that, which is a 0. Okay, we have 0 remainders. We sub negative 2 in and we find 0. So we find 0 remainders for that question. Okay. Find the remainder when I want to use that to divide by that. I can do 2 ways. I can substitute p2, and that's 2 cubed minus 3 times 2 squared plus 2 times 2 plus 6, which is to calculate whatever I have here. Or, like, I really like to use the synthetic method. I just put all these numbers down here. 1, negative 3, 2, and 6. And I'll put 2. Okay, I'll put 2. So it's 1. 1 times 2 is 2. 2 plus minus 3 is minus 1. 2 times minus 1 is minus 2. Plus this 2 will be 0. 2 times 0 is 0. Plus that 6 is 6. So that is the remainder. Okay. That remainder should give you 6. Okay, remainder is 6. For the next one, I can do 1, negative 4, 1, and 6. And I'll divide that by, so I'll put negative 1 here. That's negative 1. Okay, not 1, it's negative 1. So that's 1. Negative 1 plus negative 4 is negative 5. Negative 1 times negative 5, 5 plus 1 is 6. Negative 1 times 6 is negative 6 plus 6 is 0. So remainder is 0. Okay, no remainder. So p negative 1 should give you 0. You can check your answers. Okay, p negative 1 should give you 0. for the next question here, the function fx equals to that has a factor at this, and when fx is dividing by x minus 2, the remainder is 15. Calculate the values for a and b and hence find the other two factors. Okay, so I have a cubic now and I know x minus 3 is a factor. So f3 must be 0. And I know y divided by x minus 2. I should have remainder of 15. So f2 will equals to 15. Okay, f2 will be equals to 15. So 3 is 2 times 3 cubed plus 4a minus 3. I sub 3 in, so that's a 9a minus 3b plus 3 equals to 0. And I have this one sub 2 in. Sub 2 in, so it's 2 times 2 cubed plus 2 times 2 is 4 plus 4a minus 2b plus 3 equals to 15. So let's do this. So 9a minus 3b equals 2. So that's minus 29 times 3 is 27. 27 times 2, 54 and minus 3. So that's minus 57. Can divide by 3 on everything. So 3a minus b equals to minus 29. Yeah, 29. And then we have 4a minus 2b equals to 15 minus 3 minus that's 16. So minus 1 minus 3 is minus 4. So 4a minus 2b is minus 4. So have 2a minus b is minus 2. Okay, so we have 2a minus b equals to minus 2. And I can subtract between the equations. 3a minus 2a gives you a. Negative 19 subtract negative 2 is a plus 2, which is negative 17. So a will be negative 17. And b will be 2a plus 2 will gives you b. So b equals to negative 17 times 2 plus 2. Negative 34 plus 2, b equals to negative 32. Okay, negative 32. So let's check on that. I'm not sure if I calculate that correct. So let's say 2 minus 17 minus negative 32, which gives you positive 32 and have 3. And I sub 3 in. That is 2. 6 minus that is minus 11. 33 times that is minus 1. Minus 3 plus 3 is a 0, which is the correct answer. I can go back to check my answers. Okay, that's the correct answer. And also I know that fx then will equals to x minus 3, 2x squared minus 11x and minus 1 by using this table. Okay, because I divide by x minus 3, I have remainder 0, and I work out all the coefficient has been left, which is 2 minus 11 and minus 1. So I need to find all the other two factors. So I need to factorize the cogetic as well. So this cogetic gives me positive discriminant because discriminant is minus 11 squared minus 4 times 2 times minus 1. That must be a plus. So I have a positive discriminant. So what I can do, I can't really use a 2 and 1 to make it 11. So the way will be completing square for this. Okay, completing square for this. So I will take a 2 as common factor out first. This will give me x squared minus 11 over 2x minus a half. And I will have x squared minus 11 over 2 plus 11 over 4 squared minus 11 over 4 squared and still minus that a half here. And 2x minus 3. Remember, you still have this bracket here. You have x minus 11 over 4 squared. And you minus 1 to 1 over 16 minus 16 over 8. That's minus 129 over 16. So 129 over 16. Let's see what's 129. Divide by 3. 4, 3 cannot factorize. Then so square root of that, 4 of that, and I will square that. So it's 2x minus 3, x minus 11 over 4 plus root 129 over 4, x minus 11 over 4 minus square root 129 over 4. I know I'm going really fast, but like you need to try this question before I do this. Okay? That's why I'm going this fast. So you need to try it. Otherwise, you don't know what I'm doing here. Okay. For example 8. Example 8 is called the rational root theorem. Okay, it's called the rational root theorem. So what is rational root theorem? We have integer roots. Okay, we have integer roots. And last week I tell you how to find the roots. Okay, so what numbers worth you to try? You find all the factors for the constant and you find all the factors for the starting coefficient. Okay, for example this one, the number worth me to try is plus minus 1, plus minus 2, plus minus 1, plus minus 3. Okay, that's the thing worth me to try. I'm not sure if you have tried this at home, but if you try that, you will see none of this number will work. Okay, so have two. Okay, we have this table here, and we try a number. We try a number here. Let's try plus 1 here. That gives you 2. 2 minus 1 is 1. 1 times 1, 1 minus 1, 0. And that's a minus 3. That's not going to work. And it will be the same like if you try all plus minus 1, plus minus 2, plus minus 3. Those 6 numbers, none of that work. Okay, so none of those factors work. Then you will start to think about the rational root. Okay, so the rational root will be the factor of the constant over the factor of the starting coefficient. So you will create 3 plus minus 3 on 2. And you will create plus minus 1 on 2. You will not create plus minus 1 on 1 because that's still 1. You will not do plus minus 3 over 1. That's still 3. And you are not going to 2 on 3. It must be the constant factor over the highest like powerless factor. So it must be the back one over the front one. And that gives you 3 on 2 and 1 on 2. You create another 4 possibilities. Okay, there are another 4 possibilities. So let's try a half. Let's try a half. 1 minus 1 gives you 0. 0 times that and minus 1 is that. And minus 2 minus negative 3 is not going to work. Let's do 3 over 2. Let's do 3 over 2. 2. That gives you 3. 3 minus 1 gives you 2. And give you 3. 3 minus 1 gives you 2. That times that gives you 3. 3 minus 3 gives you 0. And that one worked. Okay, that one worked. So if that one worked, that will give you x minus 3 on 2. 2x squared plus 2x plus 1 plus 2. You can create a 2 as like all the factors. So that can be x squared plus 1 plus 1. Okay, x squared plus x plus 1. And then you can times the 2 in the bracket. It's not necessary to do that, but like you can do that. Okay, and we have a quadratic here. But the discriminant for this quadratic is 1 squared minus 4 times 1 times 1. That is smaller than 0. We cannot factorize further. So the question will stay like that. Okay, the question will stay like that. next one. Again, this question, you can have plus minus 1, plus minus 3, can have plus minus 1, plus minus 5. And from that, you can create another one is plus minus 1 on 3 and plus minus 5 on 3. Okay, another 4 here. And if you try those ones, it's not going to work. Okay, none of that will work. But like you won't know that unless you try them. But now I tell you, I'm not going to waste time to show you all the 6 answers. But none of that worked. So we'll try 3, 8, 2, and minus 5. Let's try 5 on 3. That gives you 3, and that is, let's try minus 1. That's 3 and minus 5 plus 8 will give you 3. Have minus 5 and minus 3. You have 5, that 5 is 0, so that one will work. That one will work. So what you have is x plus 5 on 3. 3x squared plus 3x minus 3. You can take the 3 as common factor, and then you can put that in here. It just looks better, okay? It just looks better, and nothing like has been changed. It just looks better. And here I can complete the square. I can plus half of the square and subtract half of the square, and still subtract the 1. Have 3x plus 5. Those 3 is x plus a half squared minus a quarter minus 1 is minus 5 on 4, so square on 2 squared. Okay, minus 5 on 4, and is that. And we have 3x plus 5, x plus a half, plus root 5 over 2, x plus a half, minus root 5 over 2, and that's it. Yep. Sorry? No, they will not ask you like which method you will use. Like you can use any method you think is comfortable, but like you just need to show some workings. Okay, so number 9 is asking you to factorize that. And if you're going to factorize this, okay, can you, like there are 2 ways to do it. The easier way will be a cubed minus b cubed. So a cubed minus b cubed will be an easier way to do it. So there's x cubed minus 3 cubed. And the formula is a minus b, a squared plus ab plus b squared, and which I asked you to remember last week. So you have x plus 3, x squared plus 3x plus 9. That one's discriminant is 9 minus 4 times 9, which is smaller than 0, cannot be factorized later. Okay, so that's it. Oh, yeah, that's minus 3. Yeah, that's minus 3. Or what you can do is, still can use the synthetic method to do it. So that coefficient is 1. For x squared term is a 0. For x term is a 0. For 27, you will have a 27. You can see 3 is the solution. 3 is the solution. So you try 3 in. Have 1. 3 plus 0 is 3. 9 plus 0 is 9. That's a minus 27, and that's a 0. Okay, so you will have x minus 3 times x squared plus 3x plus 9. If you can't remember the formula, that still can work. Okay, that still can work. Okay, to factorize this, to factorize the second one. Second one is a cubed plus b cubed. Okay, the second one is a cubed plus b cubed. So you have 2 cubed plus a over 3, the whole thing cubed. Then you have a plus b. And they have a squared, which is 4, minus a times b, which is 2 on 3a, and plus b cubed, which is 1 on 9a squared. And let's see, we have here the discriminant will be 2 on 3 squared minus 4 times that. So that equals to 4 on 9 minus 16 on 9, which is smaller than 0. I cannot factorize that further. Every time when you use a cubed plus b cubed or a cubed minus b cubed formula, what has been left for the quadratic will not be factorized for sure. Okay, you don't even need to test it. Which formula I have used to write that, which is the a cubed minus b cubed formula. Then the quadratic cannot be factorized for sure. Okay, without thinking, without testing. So if you're not like confident, you can test them. But like if you know what formula you're using, and that cannot be factorized for sure. Okay, page 10. Page 10 is to solve cubics, okay? To solve cubics. So you have so many cubics you can solve, and the easiest one will be already factorized for you and use the non-factor law, okay? So that gives you x equals to 1 or -1 or -3, okay? So no problem. This one will give you x equals to -1/2 or 3 or -1/3. Okay, all good. Make the bracket equals to 0. And then removing the highest common factor. I have some students asking me, you trying to work out the factor by the constant, okay, which is the factor of the constant. Say we have 3, -3. We'll have +-1 +-3 is the number was asked to try. And the students asked me last week, said, oh, what happened if there's no constant in the end? Like there's no constant in the end, like what number I should try? I said, that will be the really easy case because I don't have the constant, which means x will be the common factors. I can take the common factor out. I'm happy if there's no constant at the back. So I will take the x out. So I have x squared plus 2x minus 10. That gives you 0. But remember, you cannot divide x on both sides. Okay, write it here. Cannot divide x on both sides. If you divide x on both sides, you lose one answer. It's a cubic. You divide x on both sides, that will become a quadratic, and you can only solve out 2 solutions. But actually, there should be 3 solutions, which x equals to 0. Why you cannot divide by x? Because you don't know whether x can be equal to 0 or not. Okay, if x can be 0, then the whole thing is 0, and x equals to 0 is a solution. So now I'll factorize the inside. So x squared plus 2x plus 1 minus 1 minus 10 equals to 0. x plus 1 squared minus 11, which is square root 11 squared equals to 0. x plus 1 plus root 11, x plus 1 minus root 11 equals to 0. Then I have x equals to 0 or x equals to -1 plus minus root 11. Okay, 3 solutions. Have x here, 2x squared minus x minus 1 equals to 0. So take the 2 out. 2x equals x squared minus 1/2 x plus 1/4 squared minus 1/4 squared and minus 1/2 equals to 0. 2x x minus 1/4 x squared minus 16, 1 16, minus 16, 8, so it's minus 9 on 16, so 3 on 4 squared. Actually I don't need to complete the square, I can do directly solve. So minus 4 plus 3 on 4, x minus that minus 3 on 4 equals to 0. So 2x, x plus a half, x minus 1 equals to 0. So x equals to 0, or x equals to minus a half, or x equals to 1. 1, 2, minus 1, 1. So it's minus a half and x. Okay, for this one, I can have x cubed plus 2 cubed equals to 0. Then x plus 2, x squared minus 2x plus 4 will equals to 0. So x will equals to negative only, because that discriminant will be smaller than 0 forever. So that is smaller than 0. I have x equals to minus 2 for the first one. For the second one, I have 10 cubed minus 1x, the whole thing cubed, equals to 0. And what I will have is 10 minus 1x, 10 squared plus 10 on x plus 1 on x squared equals to 0. Which is 1 minus that equals to 0. So 10 equals to 1 on x. X will equals to 1 on 10. Okay, that equals to 1 on 10. So x equals to 1 on 10. And also, if you want to know what equals to that, so it's 100 plus equals to 0. So I can times x squared on everything. And the discriminant equals to 10 squared minus 4 times 100 times 1, which is smaller than 0. So no solution for this side. You only have one solution here. Okay, example 7. Example 7 is like using the grouping method. You can group them. Okay, you can group them. Let's say we group the first two. We have x squared, and then we have x plus 4. Minus, you have 3 here, and you have x plus 4, and that equals to 0. Then you have x plus 4, and then you have x squared minus 3. That equals to 0. Then x equals to minus 4. I can still factorize, not to the linear form yet. That is x plus root 3 and x minus root 3. Okay, all linear factors. Then x equals to minus 4, or x equals to plus minus root 3. Okay, for 8, I still can group the first two. I can say x squared, x minus a, and subtract 11 and minus x minus a. That equals to 0. Then x minus a is the common factor. I have x squared minus 11. That equals to 0. Then x minus a, we have x plus root 11 and x minus root 11. That is 0. Then x equals to a, or x equals to plus minus root 11. So that's for grouping. For grouping method, like, you should be able to see it first. Okay, you should realize, okay, those two look similar, and those two can give me similar factor as well. So you need to try them. Okay, you need to try them. There's no indications telling you that there must be a grouping question. Okay, no one will tell you there must be a grouping question, so you need to think about that. Okay, and if all of that is not working, okay, if all of that is not working, then I will use like what cannot work. So if there's not in the factorized form, there have a constant, there's not a, you cannot remove the highest common factor. You cannot use a cubed plus b cubed, a cubed minus b cubed formula, and you cannot use the grouping method. Then the last case we have is find the linear factor. Okay, the last thing we want to do is finding a linear factor because it takes you longer to do this. Okay, it takes you longer to do this. Okay, so what is possible here will be plus minus 1, plus minus 2, plus minus 3, plus minus 5, plus minus 6, plus minus 10, plus minus 15, and plus minus 30. And for the top one, you just forget about it. You are not going to do that like large numbers. Okay, the possible one will be 1, 2, 3, 5. So find the linear factor will be same as to find the number to have a 0 remainder. You will start with this coefficients. And you try a number. Let's try a number 1 here. So very unlikely 1 can work because if you put 1, that gives you 1, that gives you 4, that gives you 11, that gives you 30. 1, 4, 11, and 30 cannot make a 0 in any sign. Okay, no matter it's positive sign or negative sign, like doesn't matter how you change your signs, it's very unlikely to give you a 0. So maybe it's not worth us to try 1. Let's try 2. So 1, that is 2. 2 minus 4 is minus 2. And they have a minus 4 plus minus 11 is minus 15. It's minus 30 plus 30, which gives you a 0. So this one worked. So you will have x minus 2 as a factor. Then what has been left is minus x squared minus 2x minus 15. And that equals to 0. That is minus that. And you have x plus 3 and x minus 5 equals to 0. So x will equals to 2, or x equals to minus 3, or x equals to 5. Okay, question 10. When you're trying to solve a polynomials, do not put any number on your right hand side. It's always 0 because you want to use non-factor law. So I cannot accept any constant on the left, on the right. So it's 2x cubed minus that plus this minus 2. Okay, that's your first step. You must make your right hand side to be 0. And then the number worth us to try is plus minus 1 and plus minus 2. Okay, plus minus 1 or plus minus 2. Or like that gives you plus minus 1, plus minus 2. That gives you plus minus 1, plus minus 2. You can have a half. Okay, plus minus 1 on plus minus 2. You can have a half. But you won't try the factor, what is called the fraction one first. You will try the whole number one first because it's better to try those ones. So you have minus 2 here. I will start with 1. So that gives you 2. 2 minus that minus 3. Minus 3 plus 5 is 2. That gives you 0. Okay, so 1 worked. So you will have x minus 1, 2x squared minus 3x plus 2 equals to 0. So discriminant for this is 9 minus 4 times 2 times 2, which is smaller than 0. And you cannot find any values here. Okay, cannot find any values here. So you will do minus 3. So you have x equals to 1 only. Okay, x minus 1, x equals to 1 only. Actually, I save a lot of time by using this box if you avoid long division. Long division is really time consuming. Okay, so I really don't like it. So I'll encourage you to practice on this method. If you haven't really know this method before, you can try for about 10 questions. If you don't like it, it's up to you to change back to your original one. But like, at least like you try something, like about methods, try different method and see which one suitable for you, okay, which is the best one. Okay, for example 11, so choose your own way to do this. I'm not really classified that into a particular type, okay? So we have all the above types. For this one, I cannot remove any highest common factors, and for this one, can't use a cube plus b cube method. So we only have two ways. One is finding a linear factor. The second one is grouping. Okay, the second one is grouping. The first one is finding a factor, and the second one is grouping. So if you're trying to find the linear factor, the numbers are really large, okay? The numbers are really large, and there's a lot of common factors in 1089. Okay, there's a lot of common factors in 1089. So let's have a look at this. 1089. When see a big number, I would like to add the digits all together because I want to see what is the factor for that number. So if I add them, that equals to 18. 18 can be divisible by 9. So 9 is a factor in 1089. So I will divide this by 9. Let's see what happens. That gives you 1 to 1. And can you see the relationship between 2 and 1 for 2? Gives you a relationship 1 to 1 as well. So grouping may work in this question. I will change the order for this 2, and I will change the order for this 2. If I group that by 2x, you have x squared minus 1 to 1. Minus 9 here, you have x squared minus 1 to 1 as well. That gives you 0. So x squared minus 1 to 1 will be the common factor, and you have 2x minus 9 will be another common factor. And that gives you x plus 11 and x minus 11. So x can be plus minus 11, or x can be 9 on 2, because each bracket equals to 0. If you're going to find a linear factor that still can work, just takes you longer time. If you can use the grouping method, then the grouping will be like quicker. Okay, the grouping will be quicker. So, but first of all, we need to see that those questions can group, like can use in grouping method. Okay. Okay, the next lesson is sketching. Okay, the next one is sketching. I'm not going to continue. But you need to sketch this for me. Don't have much pages, but like we have two more lessons. So if you're not going to complete the whole thing, at least factorize everything for me, okay? Before next lesson, factorize everything for me, at least, okay? If you don't have time to sketch all the graphs, factorize everything, because I show you the factorize today, so factorize all the equations in the rest of your booklets. Okay, factorize them. So page 13, page 14, page 16, and page 17. Okay, for those 4 pages, you need to complete factorize for me. Okay, factorize for me before next lesson.